Starting.
You can start.
Okay, so as with every other analysis where you do look at individual lines, you will go to method, and then it's already there, so we delete it. You go method, and you would have an empty window. You would go append to select an element to be analyzed, which is cadmium in this case. We choose the most sensitive of the cadmium lines and then load it to the list. And as you can see, there is cadmium to be measured at that wavelength with the cadmium line. And to get the second element included to the list, you go append, choose iron, and at the moment we have to manually select that iron line that can be analyzed along with the cadmium line. So let's say it's that one. And you press OK. Both of them are there. At the moment they would still be analyzed separately because there's cadmium to be analyzed with the cadmium line, and then there's iron to be analyzed with the iron line. But you get this button down here which says combine lines, which you press, and then it shows you the spectral window that can be seen together by the detector. You actually just tick the box and then accept, and that's all, and it will measure both lines together, because as you can see here, the cadmium line is now not longer measured with the cadmium line, but it will be measured along with the iron line. So once that is done, okay, once that is done, you create your sequence of samples to be measured or calibration to be carried out. And what you end up with is a typical pattern, typical sequence where you have your calibration standards, and you see the iron line here being measured first, the cadmium line being recalculated after the determination of the iron was completed, and then it does that for every individual step. And you can get calibration curves for both of them. Of course, you can see spectra. So both lines are here, and you can actually see how the intensity of every individual line changes. So that was the cadmium line coming up. It goes down, and the iron line going up now. And we have the three-dimensional plot of it. You can see both of them. If you want to, you can look at them in every whatsoever direction. But let's look at the calibration curves. So this is the calibration curve for cadmium. I think it's quite a good fit given the number of lines you get here. And you can look at the calibration curve of the iron, which due to the higher concentration range is nonlinear. However, you still get quite a reasonable, or let's say a very good fit. And so as you can see, you do calibrate from one sample, and so do you analyze your sample. So this is cadmium and iron in a fish matrix. So we have some organic material, but if we scroll through the spectra, we will see cadmium coming up again, and then it goes down, the matrix coming in, and then that goes down as well, and the iron comes up. You have the chance to look at it in 3-dimension, right? So this is one matrix, and you can also use the correction model for 2 lines. Let's say we choose a correction model, correction spectrum. I've already done that. So you just need to load it. Hold on, it's loaded, and then if we look at the spectra again, what we see is that we have managed to suppress the matrix, because if you look at the sequence again, you see the cadmium signal coming up, going down, as little or less matrix, and then the iron comes up. It's actually clearer to see in three-dimensional plot. So mind you, this is the same data, we've just subtracted the matrix. It's actually quite a elegant and straightforward way of dealing with that. Yeah, so it works.